on number 86 here. A lot of you will probably have this formula memorized, but here's a quick derivation of the derivative of the arctangent formula for this particular function. If y was equal to that function, then we would first isolate the arctangent by multiplying both sides by 3. Then we would take the tangent of the arctangent, so that we're left with x over 3. At this stage, we'll do dy dx implicitly, and we'll have to use the chain rule twice. So first, secant squared of 3y times the derivative of 3y, which is 3, times the derivative of y, which is y prime. And the derivative of this with respect to x is just a third. All right, at this stage, we come back here and draw a picture of the right triangle. Tangent of 3y must be the angle, and this must be the opposite over the adjacent. Then using the Pythagorean theorem, we know that the hypotenuse will be the square root of x squared plus 3 squared. Okay, back over here, we can divide both sides by 3. So now we have secant squared of 3y times y prime is 1/9, and the derivative with respect to x of this function is really the derivative of that y with respect to x. So we're looking for y prime. So just solve for y prime. Let's divide both sides by secant squared of 3y, and from our right triangle, what is secant squared of 3y? It's this secant ratio, hypotenuse over adjacent, squared. Well, that's just x squared plus 9 over 9. So to get our answer, the derivative of this with respect to x, we need to solve for y prime. We're going to divide both sides by secant squared of 3y, which is this. So when you divide the left side by that, we'll be left with just y prime. And when we divide by secant squared, we're dividing by this, we're multiplying by the reciprocal. So on the right side, we'll have 9 over x squared plus 9. And this simplifies to just 1 over x squared plus 9, which is choice B. Notice I did this in just 2.5 minutes, and that's explaining every step. So I could have done this in a minute, and that was without memorizing any formula. It's just remembering the process that we learned in class for finding the derivative of an inverse trig function. Period A3 students, though, we haven't learned that yet, so we'll be talking about this on Thursday. Let's suppose, though, that you had this formula memorized for the derivative of arctangent. Then what would this problem look like without actually deriving it all? Well, first we'd want to have no factor but 1 in front of arctangent. So let's rewrite the 1/3 in front. And we know that you can do that with constants when you take derivatives. All right, and then our function u is x over 3. So u prime will be 1/3. All right, so what is our derivative then using the formula? 1/3 times, follow the formula, u prime, which is 1/3, all over 1 plus u squared. Well, 1/3 of a third is a 9th. So we have 1/9 of 1 over 1 plus x squared over 9. And so if we simplify that, what do we get? We get 1 over 9 plus x squared, which should be consistent with what we got when we didn't use the formula and actually derived the derivative. Bingo.